Let's take the practice test. 2.09 radical and polynomial operations. Okay, with number 1, simplify the sixth root of x times the sixth root of x times the sixth root of x times the sixth root of x. So probably the easiest way to do this would first be able to, let's change these to exponents, because we have some rules we can do with exponents. So the sixth root of x would be x to the 1/6. Right? So if we multiply that times itself 4 times, so we have x to the 1/6, x to the 1/6, x to the 1/6, x to the 1/6. Now we can have our rule of exponents. And it says when we multiply the same base, they're all x raised to a power, we multiply, we add their exponents. So that would be x to the 4/6, because 1/6 plus 1/6 plus, they all have the same denominator. So we just add the numerators, x to the 4/6. Now let's convert that back. We don't have an x to the 4/6. We do have an x to the 2/3. We do have an x to the 2/3. So this does 4/6 does simplify to x to the 2/3. That would be the most accurate answer. Otherwise, if we convert it back, the 4 is to the power, so it's to the 4th power, and that would be to the 6th. But simplified, it would be x squared to the 3rd, and we don't have that as a choice. Well, this 6 is out front, multiplying 6 times the square root of x, and multiplying 4 times the 6th root of x. None of those are correct. We're not doing anything like that. So this is the most accurate answer. We simplify that, and we end up with that. That's 4/6 as a fraction. That simplifies to 2/3. Okay, rewrite 5 times. Now this is one of those times. So this is 6 times, 4 times, 5 times the 9th root of x to the 4th power. See, rewrite that in the radical form. This is a 5 times. So this is a 5 times. So that looks like that's almost going to be 5 times. So x to the 4/9, let's just make sure that's right. The 9th is the denominator, so that's what goes outside the 9th root of x to the 4th, and then all that's being multiplied by 5 out front. So it is that one right there. The 5 is being multiplied out front. Okay, rewrite the 8th root of x to the 3rd. So since it's x to the 3rd, that goes on top. Since the root goes on the bottom, that is the same as x to the 3/8. This one is x to the 3/8. If you can see that, it's pretty small on your screen. Maybe I should be working a little closer down here just because of how small some of these fractions are. All right, we'll work at that height. X to the 3/8. All right, next problem. Simplify the 3rd root of x squared times the 3rd root of x squared. Write the answer using a rational exponent and in radical form. So x squared to the 3rd power, to the 3rd root, x squared, but the root is there, times the same thing. Right? So when you multiply, our rule says if we have both the same base or both x's with exponents multiplied by each other, we add them. So 2 plus 2 is 4 thirds. They have the same denominator when we add fractions. So it's x to the 4 thirds. So how does that work in radical form? Remember, the 3 is the denominator, so that is going to be the third root of x to the 4th power. But that's not one of our options, so this needs to be simplified further. This is the same as x to the 3 thirds times x to the 1 third, right? We just divide up the fraction differently. X to the 3 thirds is just x to the first power. All right, so that's x to the first power times x to the 1 third power. Well, that's just x, and to the 1 third would be the cubed root of x. So this is taking this and simplifying it further to give us that answer right there. This was not in our list of options. So we needed to further simplify it because this is greater than 1. So that means we've got a full x in there. And we needed to simplify it further since that's greater than 1. So look for that. If this is greater than 1, 4 thirds is bigger than 1 because 3 thirds is 1, and we got an extra third. Look to simplify that. All right, let's move down. Divide x to the 3/5 minus x to the 1/4. So we know when dividing, that means we subtract the exponents. That's the same as x to the 3/5 minus 1/4. Well, for fractions, we have to subtract, we have to have the same denominator. So 4 and 5. If we multiply this times 1, and here's what my 1 looks like, and multiply this by 1, so 5/5 and 4/4, this becomes 12 20ths minus 5 20ths. See, the common denominator was 20. When you have 5 and 4, they both can go into 20. So this one, if we multiply everything by 4, that's 20ths. Multiply this by 5, that's 20ths. So that is 7 20ths now. So x to the 7 20ths, which is that choice right there, x to the 7 20ths. All right. This is a power to a power, x to the power of 2/7 taken to the power of 3/4. So in that case, we multiply the exponents. So we take 2/7 times 3/4, which when you multiply fractions, you just multiply straight across. 2 times 3 is 6. 7 times 4 is 28. Now that would simplify because those are both divisible by 2. So that's the same thing as 3/14 because we just divide by 2 on top and bottom, and we get 3/14, which is the first choice right there, 3/14. 3/14. All right, let's move on. Number 7. This is multiply x to the 3/4 times x to the 1/5. All right, when we multiply two x's that have exponents, that's the thing is adding x to the 3/4 plus 1/5. So again, this is like subtracting. We have to have the same denominator. Again, 20 is the most common denominator between the least common denominator between 4 and 5. So we take this times 5 on top and bottom. We get 15 20ths. Plus, we take this on 4, top and bottom. Take it, multiply it by 4, 4 20ths. So when we add those together, we get 19 20ths. So this is x to the 19 20ths, which is this bottom option right there. Wish that was bigger on your screen, guys. So, all right, simplify 49 to the negative 1/2 power. Negative 1/2 power. Okay, so first off, let's look at the fact that it's a negative. To make it a positive, we move it to underneath into the denominator, right? Because this is just like over 1. And if you have something raised to a negative power, you have to move it to the other side of the fraction. If this started out underneath the 1, we would move it to the top, but it didn't. It was just a 49 to the 1/2. So if we make it 1 over 49 to the 1/2. Now, what is 49 to the 1/2? Okay, if we change that to radical form, 1/2 means square root, right? The 1/2 power square root, because it's the 2 out here, which is what it always is. If we don't put a number out there, it's assumed to be a 2. Square root of 49 to the first power. So that's the first power. So just square root of 49. Well, what's the square root of 49? 7. So when we simplify that, 1/7. When you do converting the radicals to fractions, we don't consider the negative square root, because 49 actually has 2 square roots, 7 and -7. But when simplifying these, we assume the positive. 1/7. All right, find the solution of the square root of x plus 2 plus 4. Notice the plus 4 is outside the radical, equals 6. And then we have to determine if it's extraneous. So the first thing we need to do is move this to the other side, because it's not under the radical. We need the radical by itself. So when we subtract 4 from both sides, that gives us the square root of x plus 2 equals 6 minus 4 is 2. All right, we're trying to solve for x. We've got to get rid of the square root. So if we take the square of both sides, we square both sides. Squaring cancels out square rooting. Those are inverse operations. They're opposite of each other, which means this is now just x plus 2. And 2 squared on the other side is 4. Subtract 2, x equals 2. Now we have to figure out, is this extraneous or not? Okay, so let's go back to the original equation. Take this answer, substitute it in. 2 plus 2 plus 4 equals 6. Okay, so 2 plus 2 is underneath the square root. So that means that's 4 plus 4 equals 6. What is the square root of 4? Again, we only assume the positive value. We don't assume the negative. When we're checking these radicals and converting, we're going to take the positive 2. Plus 4 equals 6. 6 equals 6. So our answer is 2, and it is not extraneous, because when you substitute it back in, it works. So we had both options. So we had to check. It is not extraneous. Number 10. Okay, here's another one. Find the solution of this and determine if it's extraneous. Well, the first thing we have to do to get this, we have to get the radical by itself. So it's being multiplied by 3. We divide by 3. So that gives us square root of x plus 5 equals -9 divided by 3, -3. Okay, now that we have the radical by itself, we'll square both sides. X plus 5 equals -3 times -3 is a positive 9. Subtract the 5, x equals 4. Is this extraneous? 3 times the square root of, not x, because we're checking the answer, 4 plus 5 equals -9. 4 plus 5. 3 times the square root of 9 equals -9. Square root of 9 is 3. 3 times 3 equals -9. 9 equals -9. X equals 4 is extraneous. It is extraneous because this was not a true statement. All right, identify all. Well, that gives a hint. There's probably more than one. Solutions of x plus 8 minus 6 equals x. So again, let's get the radical by itself. Plus 6. So that gives us the square root of, not 8. X plus 8 equals, on the other side, we cannot combine those because they're not the same. X and a 6, x plus 6. Now we have to square both sides. Squared. When we square a square root, those cancel each other out. So we have x plus 8 on this side And over here, we have x plus 6 times x plus 6. Or, say x plus 8 equals x times x is x squared. X times 6 is 6x. Now we have to distribute the 6. 6 times x is 6x. 6 times 6 is 36. Okay, we can combine those. They're both x's. So let's move up here. X plus 8 equals x squared. We can combine those because they're both x's. 12x plus 36. Okay, we've simplified it to this. Let's move. This is quadratic. So that means we need to set it equal to 0. So let's subtract this x and this 8. So we've got 0 equals x squared plus 11x. We had 12x and subtracted 1. Now we have 36 and subtract 8. So we have plus 28. Okay, we can use the quadratic formula if we like, or we can factor this, right? So factoring it, we need two numbers that would multiply to be 28 that add to be 11, and these are all positive. So I see some of you factoring this way where we can break that into a 4x and a 7x because those would add up to be 11, and they multiply to be 28. All right, so this is, we can factor out an x, and it leaves x plus 4. And here we can factor out a 7 out of those two terms. That leaves an x plus 4. So 0 is x plus 4 times x plus 7, because this is the x plus 7. We factor x plus 4 out of both those. That leaves x plus 7. So that means x equals negative 4 and negative 7. If that's 0, 0 equals x plus 4, x must be negative 4. Negative 4 plus 4 equals 0. Or negative 7 plus 7 equals 0. There it is, first answer. Now, before we move on, I do need to correct myself here. I did not go back and check to see if either one of these were extraneous. So adding this in here, we see the negative 4 works as a solution. And so negative 4 equals negative 4 is when we get to the bottom, and that is in the solution. But the negative 7 turns out to not be a true solution. So we have to throw that one out. Don't forget to double check. The answer is just x equals negative 4. Find the non-extraneous solutions of this. All right, so this is going to be similar to above. We have two different x's, so we're probably going to have some quadratic work to do. Add 5 first off. Square root of x plus 6 equals x plus 6. All right. Square both sides. We just did x plus 6 up here, so we already know what this is going to simplify to be. X plus 6 equals, we can just borrow from that, x squared plus 12x plus 36, since we just solved that. Now let's move this x and this 6 to the other side. So 0 equals x squared plus 11x again plus 30. Okay, now we've got plus 30. So we need two numbers that add together to be 11 and multiply together to be 30. So 0 equals x. I'm going to factor the other way this time. I'm just going to jump straight to the factors. Skipping this step if you know what the factors are. If you know the factors, you can go straight from this to this. Some people use this method. It's like I have to add together to be 30, and I have to multiply together. Oh, I'm sorry, add together to be 11, multiply together to be 30. This adds, this is multiply. And I know 5 and 6 will do that. 5 plus 6 is 11. 5 times 6 is 30. So I know 5 and 6 are my numbers, both positive. So that means x equals negative 5. or -6. And they only want the non-extraneous. So let's test first. -5 plus 6 minus 5 outside the radical equals -5 plus 1. There's two different x's. We have to substitute -5 in for both of them. -5 plus 6. So that's the square root of 1 minus 5 equals -5 plus 1. So square root of 1 is 1. 1 is 5. -5 plus 1. 1 minus 5 is -4. -5 plus 1 is also -4. 5 checks out. So we know for sure 5 can't be the -5 one. It's either 5 or else they're both non-extraneous. So let's check 6. Square root of -6. Oh, sorry. I scratched up the wrong ones, didn't I? Because we're checking positive ones. These are negative answers. So it's either -5 or it's -5 and -6. It can't be the positive ones. All right. I'm rushing through here. I'm making some mistakes. So got to be careful. -6 plus 1. Okay, so we've done the -6 substitute in for both x's. -6 plus 6, square root of 0. So that's just 0. So this is just -5. -6 plus 1. What is -6 plus 1? It's -5. Oh, both of those work out. Neither one are extraneous. Neither one are extraneous. So they both work. Number 13, simplify. This is I to the 31st. Remember, there's 4 different things. I squared, I to the 3rd, and I to the 4th. That everything ends up. I is the square root of -1. If we take that times itself and square it, we end up with just -1. I to the 3rd is -1 times the square root of -1, which is these two together. I second, I the first. And then I the 4th is I squared times I squared, which is -1 times -1, positive 1. This is all the possibilities it could be. Which this is just I. I the first is just I, just squared -1. So it's either going to be that 1. This is the same thing as -I. All right, so there's the 4 choices. I, -1, -I, or 1. Which one is it? To the 31st, we divide 31 by 4 because there's 4. It keeps looping around every 4. So this goes in there 7 times, 28. The remainder is 3. 1, 2, 3. It's the same as the 3rd power. So -I is our answer. If we take I and multiply by itself 31 times, we'll end up with -I. There you go. Simplify the square root of -100. Well, that's the same as the square root of -1 times the square root of 100. The square root of -1 is I. It's an imaginary number. The square root of 100 is 10. So that's the same thing as 10I. Right? I times 10. All right, simplify this. 7 plus I minus 6 minus 2I. Well, we have to separate out, and we can only subtract real numbers from real numbers and imaginary numbers from imaginary numbers. So 7 minus 6 is 1. I minus -2I means we're adding 2I. So that one. Because we subtracted a negative, which means we added I plus 2 more I. Remember, you can only combine the reals and the imaginaries. Number 16. Well, that page went quick. All right, simplify this. These are multiplied together. Multiplied together. Okay, so that we distribute when we have 2 things we have to distribute to get rid of the parentheses. So we're going to multiply 6 times both of those, and then we have to come back and multiply I times both of those. So let's do the 6 first. 6 times 8 is 48. 6 times negative 3i is negative 18i. Okay, now let's multiply I by both things in parentheses. I times 8 is plus 8i. And I times negative 3i is negative 3i squared, because I times I is I squared. So let's combine and simplify. So 48 minus 18 plus 8i. Those are both I, so now it's negative 10i. Negative 3i squared is the same thing as negative 1, right? Because that's the square root of negative 1 times the square root of negative 1. So that just means it's negative 1, because the square root times the square root is the same thing as squaring it, which cancels each other out. So this is a negative 1. Negative 3 times negative 1. That's plus 3. See, because negative 3 times negative 1. That's what that is. So it's positive 3. So 48 plus 3, 51 minus 10i. That's all we can do. We cannot combine those. This is imaginary. This is a real number. Here it is. First choice up there. 51 minus 10i. Ooh, simplify here. All right, we have a polynomial and another polynomial, and it wants to add. Well, again, we can only add like terms. X squareds. We can combine the x squareds. So what is 6x squared plus 2 more x squared? That's 8x squared. Now these are x's, 11x and minus a 17x. If I'm adding a negative and a positive, the negative is bigger, so I got negative 6x. And then these are the constants. If I add a negative 3 plus a negative 4, I've got negative 7. There we are. Negative 7. Okay. Let's look at this one. This is subtracting. Same thing. We can only do like terms. X third. What can we subtract from that? There's not an x to the third at all. So x to the third is by itself. How about x squared? There's an x squared, but we don't have one over here. So we have 0x squareds over here. 0x squared minus 2x squared is minus 2x squared. We have an 8x and a negative 3x, and we're subtracting. Subtract a negative, that means add 8 plus 3. And then we're subtracting a negative 12, subtracting a negative, add 12 to the 5. X to the third minus 2x plus 11x plus 17. There it is. We had no terms to combine for those two. There's only one x to the third. There's only one x squared. All right, how are we doing here? We got 2 more pages. That's it, 2 more pages. Simplify 3x squared times the polynomial in parentheses. All right, focus. So we have 3x squared times this polynomial in parentheses. So it's just distributing, right? We'll just distribute it to every term. Distribute to every term inside. 3 times 7 is 21. X squared times x squared is x to the 4th. 3 times 2 is a positive 6. X squared times x, x to the 3rd. 3 times negative 4. X squared times 1. Basically, there's not another one. So negative 4 times 3x squared is negative 12x squared. So this is our answer, which looks like it matches up with this one right there. All right, solve for the area of a rectangle whose length is this and the width is this. Well, remember the area of a rectangle is length times width, which means we need to take x plus 4 and x minus 9 and multiply them together. Distribute x times x, x squared, x times negative 9, negative 9x. 4 times x, 4x. 4 times negative 9, negative 36. Just distribute each, right? We can combine the like terms. X squared doesn't have a like term. It's the only x squared. We have a negative 9x and a positive 4x, so that sums out to be negative 5x. And then we have the negative 36 right there. All right, we have another one. Multiply this binomial times this trinomial. So we have to distribute 3 times. And then we have to distribute again 3 times with the negative 1. Because both of these terms have to multiply times everything in the parentheses. So x times x squared is x to the third. X times 5x, 5x squared. X times 2, 2x. And then negative 1. Negative 1 just changes the sign of all those. Negative 1 times x is negative x squared. Negative 1 times 5x is negative 5x. Negative 1 times 2 is minus 2. Now we just combine the like terms. So x to the third, that's the only x third. There's not another one, so it stays out front. X squared, we have the 5x squared, and we have a negative 1x squared. So 5 minus 1, 4x squared. Then we have 2x and negative 5x, so 2 minus 5, negative 3x, and then we have this minus 2 on the end. So x to the third, 4x squared, minus 3x, minus 2. That was the only one that's really even close to what we had there. All right, last page. Word problems. All right, word problems. Frank and Gertrude mow lawns for extra money over the summer. Frank's income is determined by this. All right, so I'm going to highlight that so it doesn't get lost. Fx equals 5x plus 15, where x is the number of hours. So this is the number of hours, and that's how much money he makes, income. Gertrude's income is right here. G of x equals 4x plus 20. If they were combine their efforts, then h of x would be adding those two together. All right, so if we add those two together, that's how much money he makes. So let's assume Frank works 4 hours. Create function hx, which it tells us what to do, add those together, and indicate if Frank will make more money working alone or by teaming with Gertrude. Okay, so first off, let's figure out how much Frank works alone. If he works 4 hours, right? 4 hours. So that would be f of 4 would be 5 times 4 plus 15. So 5 times 4 is 20 plus 15. Frank makes $35. All right, $35. How about h of x, where we add these together? So 5x plus 15 added to 4x plus 20, like terms, that's 9x plus 35. So what if, that's h of x, that's what our h of x is, right, when we add those together. So what is h of 4 then? If he works 4 hours under this when he's working with Gertrude? 9 times 4 plus 35. 9 times 4 is 36 plus 35. So $71. So 9x plus 35 right there. And it makes more money, even if he gets half of this. Even if he's still 35 and a half. It's still more than the 35. So he should team with Gertrude, because adding those together gives a higher amount. Given the functions f of x equals, let's highlight these again. 4x plus 1, g of x equals 2x plus 4. Which operation results in the smallest coefficient on the x? All right, so we have to add them, subtract them, and multiply them. So if we add these together, right, so negative 4x plus 2x, we can only put like terms together. So add in together, f plus g equals, here, well, f plus g of x. We'll write it properly. F plus g of x equals. So add these together. Negative 4x plus 2x is negative 2x. Negative 1 plus 4 is plus 3. So there is what they are added together. F minus g of x. So we're subtracting this from the first one. Negative 4x minus 2 more x minus negative 6x. And then negative 1 minus 4 is negative 5. And then finally multiplying them, we got negative 4x times, remember we have to distribute both of these. Negative 4x times 2x is negative 8x squared. Negative 4x times positive 4 is negative 16x. Now we have to distribute this. Negative 1 times 2x is negative 2x. Negative 1 times 4 is minus 4. So this is negative 8x squared. These are like terms. Negative 18x minus 4. So what is the coefficient of the x term? Coefficient there is negative 2. The coefficient there is negative 6. The coefficient of the x term is negative 18 because that's the x term. All right, x. This is x squared. That's not the x term. But still, multiplication has the smallest coefficient. Negative 18 is smaller than negative 6 and negative 2. All right, last problem. Samantha works at a bakery. F of x represents the amount of money she earns, and x is the number of cookies. So this is the amount she earns per cookie, and x is the number of cookies. G of x represents the number of cookies she bakes in an hour, where x is the number of hours. Find f of g of x. So f of g of x. Okay, so this problem has left off. It did not give us what f of x equaled or g of x equaled. So there's no way to come up with one of these. So I'm going to remove this question from the practice test because there's no way to work that without having the two functions to combine in there. So we're done. There you go. If you have questions on any of these, get with me and do well.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.